So today, guys, we're going to be looking at the chain rule. So last year we gave you these sort of questions. And we told you that you can't do anything, that you have to multiply out the brackets first. So you multiplied out the brackets and you got 9x squared times plus 12x plus 4. And then you differentiated. So if that was y equals, then you've got y dash equals 18x plus 12. So you'll see that I'm mixing up dy by dx and y dash. It doesn't actually matter, or f of x dash. They're all the same thing and they're all acceptable notations. What I want to do now is say that if we had a question like this one, y equals x plus 3 to the power of 4. It's going to take us a long time to multiply this out. Let's have a look. We multiply this and make it x plus 3 squared times x plus 3 squared. We're going to get x squared plus 6x plus 9 times x squared plus 6x plus 9. Then we have to go right through it again. So we're going to do x squared by all of these, x to the 4 plus 6x squared plus 9x. That should be a 3 squared. And then we do the 6x plus 6x cubed plus 36x squared plus 54x. And then the 9 plus 9x squared plus 54x plus 81, which if we rewrite nicely, x to the 4, how many 3's have we got? We've got 12x to the 3's. How many squareds? We've got 9, and 36 is 45, plus another 9 is 54x squareds. Then we've got 54x, and 54x makes 108x and 81. Hope that's right. If it's not right, fix it in your notes. And then we can differentiate. Whoopee! So we get 4x cubed plus 36x squared plus 108x plus 108. And the more complicated this is, the longer it'll take you to get to the answer. But what we didn't tell you last year is there's something that's called the chain rule. What the chain rule says is that we've got functions inside functions inside functions. And if we start from the outside and start to unwrap them, we can get to the answer. So I always talk about this as having a present wrapped up. And we have to undo the first wrapping before we get to the second wrapping and undo that. So it's like pass the parcel. So if we look at this one here and we say, right, let's say that this one y equals x plus 3 to the 4. Let's say that x plus 3 is a present. Like this. Nice little present with a bow on it. If we treat that as something, just a function, we can just get rid of this 4 first by using our formula. So y dash equals 4 present to the power of 3. The problem is that now we've unwrapped it, we now need to differentiate what's inside the present. So inside the present was this, and that differentiates to 1. Now, because it's 1, it doesn't change. So the answer to this, that thing there, actually is 4 times x plus 1. And if we expanded that, we'd find that out. All right, we're not going to do that, but you can do that if you wanted to. So expanded, this equals 4x cubed plus 36x squared plus 108x plus 108. All right, so that's how it works, but what we need to be able to do is we need to be able to do multiple of them. So I'm just going to rub this side here out. We're going to have a look at a harder one. So let's say we've got 3x plus 4 squared to the power of 3. All right, keep going, rubbing out. So if that's equal to y, keep forgetting that bit, then when we differentiate, y dash equals. So we've got to remember we've got a present. So the not president, because he's useless, is, oh, I shouldn't say that, is what's in the red box here. Okay, so the present is 3x squared plus 4. We don't deal with that to start off with. We're only dealing with what's around. So we'll be pretending that it sort of says 5x to the power of 3. What does that differentiate to? So 5 times 3, take the power, multiply by it, 15. Present, 3x squared plus 4, and decrease the power by 1, 2. Now we have to look at what's inside the present. So inside the present, we've got this, and we tack it on the end. This is where brackets start to come in, guys. In differentiation, it's really important that we put all our bits and pieces in our brackets so that we don't get confused about dots and things like that. So we're going to differentiate this and put it in a bracket on the end. So 2 times 3 is 6, decrease the power by 1, 4 vanishes, we've got that. Now, in the exam, we're allowed to leave it like that, all right? So leave here. They just want to know we can do the chain rule. The problem is, in your books, they don't like it like that. They want you to prettify it. So the likelihood is that they will have 6 times 15, 90x, and then 3x squared plus 4. They won't go as far as to expand the brackets, but they will put it all together as much as they can. So that's a medium type of a one. Now we have the really hard one. So the really hard one means that we've got even more than that going on. So we might have something like this. Oh, y equals. All right. You don't necessarily have to have the y equals. It's just that if you have the y equals, then you can say that the derivative, or the thing that's left once you've differentiated, is as y dash equals. Okay, so we've got this lovely mess here. So we're going to rewrite it. I'm going to bring this half up to the front because it's annoying. We might have negatives to deal with. We might have fractional powers to deal with, or surds. We just have to deal with all of them first and get it into a pretty form that we can do. So what the problem is here is that here we've got one present. But here we've got a second present. And remember what I said? We have to unwrap it from the outside in. So we don't worry about either present yet. We just deal with the outside part. So 3 times a half, 3 over 2. What's in the big present? 5, 4x cubed plus 3. And decrease the power by 1, 2. Now we go into the big present. So what does the big present differentiate to? The 3 drops off. The 5 hasn't got a power, right? So we've got like 5x here. So what is that going to go to? Right, 5 is just 5. Now we go to the inside present. What does the inside present differentiate to? 12x squared. So that would be our answer. The outside, the big present, the little present. Now, that's quite unusual to have that 5 because normally there'd be a power on that bracket or something. So you'd have 15 and then the little present, whatever. But in this case, there's nothing on that power, which means if it was an x, it would disappear. So it's disappeared for us. Okay, so now it's time to do some work on that. And we'll see you tomorrow. And one more example, guys, that I forgot. So adding this one on. If you've got something like this. All right. Then again, you've got that present. That present is underneath the square root sign, the surd sign. So this is your present here, all right? So you have to think about that. But before you do anything, you have to rewrite it. So you rewrite it as present to the power of 1/5. Okay? Now when you're differentiating it, so dy by dx this time equals, take the power, multiply by it, 1/5. Then write the present down, 3 plus 2x minus 5 over x squared. Take 1 away from that is -4/5. All right? Now you have to multiply by the present differentiated. So 9x squared plus 2. And remember this one equals 5x to the -2. So we've got -10 minus makes plus 10x to the -3. And you can get really, really, really long lines of this stuff, all right? And the answers, they're likely to have this rewritten with something to do with a surd and all sorts of other things. And because it's a negative, this will be on the bottom and this will be on the top, and this might have returned to an over the top. You just have to work with that. Usually I have my answers in the classroom, which has all of them written like this, because you don't have to simplify them in the exam. We don't want you making any mistakes, so we don't want you simplifying them, because if you're making a mistake when you're simplifying, they will fail you on it. So we leave it at that very first row, which shows that we understand the chain rule. Okay, guys? Well done.